So now that we've covered the theory, how after-treatment systems work, the key components, and the logic behind them, the real question is, where do you actually start when it comes to diagnosing a machine? This is where the process really matters. Having the right steps to follow and using the right tools is what separates guesswork from real diagnostics. That's why in the next section, we're going to move from theory and into practice. You'll see how to apply what we've learned using diagnostic tools like Jaltest to work through some real problems step by step. To walk us through that process, I'm going to hand it over to our lead technical account manager. He's going to show you exactly how to approach diagnostics in the field, from the first checks to pulling data to confirming a repair with confidence. Let's dive in.
Hi there, welcome into another demo tutorial with Advanced Diagnostics. For the sake of this demonstration, so we can just get deep into the diagnostics world, we're going to choose a 944 wheel loader from John Deere. We have 3 different variants, and we want to just step in and see what's the scope when we are trying to do an advanced diagnostic procedure with one of these engine control modules. As you can see, we've got central computer, gearbox system, and engine coverage for this particular 944K wheel loader. We want to jump in straight to the ECU level 22 interim final tier 4 configuration standard for emissions on this diesel engine. Right, so first we need to focus on physical inspection and address any system alert, any light indicator we can have on the instrument panel of the equipment. When it's always related to after-treatment system fault codes, we're gonna just get the regular failures on the instrument panel with a warning lights indicator, accompanied with a physical inspection, right? We need to understand what's the scenario of each of the machines. So before jumping to the fault code readings or clearance and checking that freeze frame data recommended, we're gonna just have a quick overview of what's going on with this specific machine, right? We need to check if there is a limp mode active into the system. We need to check if we have limited torque or horsepower output on the engine. We need to see if the engine can run at idle or even not start, right? So after we just focus our mentality into this, we're gonna just quickly connect our scans tool, in this case, switch the ignition on to the on position, test some voltages here, and also test some communications within the Jaltest link. Right, once we have test voltage, power supply, and also we have test communication lines, we're gonna quickly connect to the controller, in this case the engine control management system, and we're gonna quickly jump into the fault code readings, right? As a very first step, we need to understand that the fault code readings are gonna give us a clear idea with the information that we have previously collected. We're gonna see a good direction on where the problem on the after-treatment system module is sitting at there, right? In this case, for the sake of the video, we're looking at after-treatment system fuel meter and pump. Supply voltage is too low, right? So we see there is a couple of different nature fault codes, but we're gonna focus on the after-treatment fuel meter and pump, right? We need to check as well, not just the state of the fault code. We can see these categories. This red icon with an X means there are active fault codes or permanent status fault code. We regularly missed out checking out those saved fault codes that were generated in the history of our Jaltest diagnostic tool, and we commonly overview them, right, and just go ahead and clear them out. I want to just let you know that it's really important to just take a look at those temporary status fault codes, because they are going to give us important information on any other related active fault code that we might have present on the system, right? So it's super important to try to address those as well. Save it on your diagnostic report that's been automatically being created here and generate, so we can just go around that information as well. And usually those permanent status and temporary status fault codes are deeply related, right? So very important to jump into the freeze frame data. Freeze frame data tab is going to give us important information about the first and last occurrence of the fault code. We can see some of the pressures, certain conditions the machine was running, to see what was happening at the moment of the triggering of the fault code. Maybe we can see if the machine was under load high pressures while performing road tests, or see if our machinery was at idle when the trigger was set up into the system, right? We can see the warning lamps on the instrument panel are active, And also this is a permanent status fault code. We can see temperatures, we can see some of the conditions of the particulate matter on the NOx sensors, differential pressure sensors, so forth and so on. Each of the components that have a different role into an after-treatment system. So after we have reviewed the freeze frame data, we can recognize any particular issue that could be possibly generating the failure. We can just quickly jump into the help and components of the fault code. We can see components related to the fault code. We can see, in this case, the after-treatment fuel dosing pump, right? If I'm not sure about this particular component in my system, I can just click here on see the information of the component. After we see the information of the component, I can have information about pressures, operational data, frequencies. I can see pinouts, right, power supply lines, and CAN communication buses located on my engine, right? If I'm not sure about where is this component pinned out to the engine control management unit, I can just quickly run quick schematic and see the pinouts on the electrical wirings and all of our system components. As you can see here, we've got this component highlighted into a pinky color there, and you can see the power supplies, positive, ground are coming from here. We can see the 6 goes straight to the 17 on the engine management control unit. I can also double check what are those X ports in which we're going to have the pinouts reference into the diagram, right? More important information as we go and check these physical connections, right? Regarding the nature of the fault code, we might need to see fault code troubleshootings as well, right? And the fault code troubleshootings is nothing different than just following a diagnostic procedure, right? After we have all of the information, it's very important to understand the nature of the fault code. As you can see here, I can quickly identify and see this has to do with a physical inspection. We're gonna test, we're gonna run system checks within the fuel metering pump, but we're gonna also need to do a physical inspection. That was something important when accessing to the smart guides and troubleshooting step by step, right? We're gonna need to follow some manual procedures, right? Check the state of the component and connector pins as we refer to the electrical wiring schematics. We gotta go and check the wiring connections to see if we have any corroded pins, for example, or loosened cables. Then we're gonna run the system check with the error purge of the system. We can quickly jump in straight to these special functions, and then we're gonna go ahead and perform some manual inspections, right? Engine off, connect the components, and we can do an engine wiring test as well, right? If we have performed any of these step-by-step fault codes, we're gonna then again need to do hard resets on the after-treatment system. We personalized our after-treatment system process. Very, very important to identify the kind of system fault codes we have. In this case, we're gonna need to do these manual inspections, and then again just run a fault code clearance to see if we have wipe out any active fault code, right? Then we need to jump into the maintenance part, in which we're gonna just see what are our options. Usually, this particular filter regeneration, it's one of the first things we try to perform, but then again, we have several conditions before running an after-treatment force regen. We need to check sensors, we need to check wiring, we need to check system components, valves, to see if they are in good condition, because we will have just another unsuccessful regeneration if we are not meeting certain conditions, right? So then again, this is a very important part, but just don't go always straight forward to force regen before checking freeze frame data, live measurements, and even running system checks, right? I'd say this is one of the latest steps we need to do when running these after-treatment fault codes. As you can see, we have some of the conditions that the computer will provide us. Check the soot content running over a particular filter. We need to see the particular filter regeneration system state, and also engine request speed control conditions, right? So yeah, we're gonna check a different, for a similar model, a different nature of fault codes, right? Let's just quickly jump into the 944X module type. We can access to the engine control management unit, and you're gonna see related system fault codes on the after treatment. Then again, we're gonna see more sensors there, right? So then again, we're gonna do a physical inspection on the temperature sensors. In this case, the exhaust gas after treatment, after the particular filter is not operating well. We have an after treatment fuel injector, so we can see this is a completely jammed machine, right? And we can think about being on a limp mode, right? And power reduction system status, or inducement mode in the case of the John Deere control units, right? What do we do here? We need to definitely run an inducement mode maintenance, right? Why is that? Because everything that is not working fine will be canceled by the inducement mode reset, right? So this will allow us to have a normal operational conditions within the engine, like for 15 to 30 minutes. After we run an inducement mode reset, we can just quickly jump into the test. This is basically an advanced system check, which we're gonna have a way to run any region, run system checks to see if the system is fully operational or if there's specifically a component we might need to check, right? So this will be first thing to do. Then we can just try to do a hard reset on the after treatment fault codes, run this clearance, meet certain conditions with the engine running, and then we're gonna have a way to just filter out any unnecessary information we might be getting from that computer, right? After we have done this, it's always advisable to run a particular filter regeneration. If we have already replaced any system components that were faulty, we can just quickly jump into our forced region, right? Again, we need to check and meet some criteria there. Let's just say we are on point. We can just start forcing this region. Regions can take around 45 minutes to 1 hour, depending on the system, and then we're active, running. We're gonna be sensing live measurements such as particulate per million NOx sensors, pressure sensors, differential temperatures there on the catalytic converter and SCR, and we're gonna be having a clear picture of what happened during that particular region, right? So after we run the region, next step, do a differential pressure reset. This will basically put to zero any counters or unsuccessful regenerations that have been stored on the ECU for the after treatment system, and this should definitely clear out everything on after treatment system lit modes or power reduction inducement modes, right? This is one of the latest. And then again, after we run this process, it's always important to run system checks for the after treatment system. We can see verification of the SCR system fault code reports. We can see maximum flows of the DEF pumps and quantity measurements of the AdBlue system. We can do the after treatment fuel dosing pump and urge ports as well. Can be run from this particular scenario. After we check a couple of these, we have a way to say our system is back on and at full power, right? If you have any questions, we can continue just looking at specific cases and we can drive you through that particular issue, right? Thank you.